Let's talk about the distance formula. Okay, so you can see here's the distance formula. It's d is equal to the square root of x sub 2 minus x sub 1, all of that squared, plus y sub 2 minus y sub 1, all of that squared. Now, you're going to run into two cases when finding the distance formula. Sometimes you'll be given 2 points and asked, hey, just find the distance between these 2 points. Other case you'll run into is when they give you a graph and they say, hey, find the distance from this graph, from this point to this point of this graph. Now, when they give you the graph, you're going to look at the endpoints. So what you have to do first is you have to determine the ordered pair for the endpoints of the graph, and then you can plug those values into the distance formula. Okay, so when you're labeling the points as x sub 1, y sub 1, x sub 2, and y sub 2, like here, it does not matter which point you choose to label as x sub 1 and y sub 1, or x sub 2 and y sub 2. The answer is going to be the same no matter what. Okay, so what do I mean by that? So find the distance between the points 2, -5 and 7, 4. Now I can go in and say, okay, I'm going to label this as x sub 1 and y sub 1. This is x sub 2 and y sub 2. I could do that, or I could label them as, hey, this is going to be x sub 2, y sub 2, and this is going to be x sub 1, y sub 1. It does not matter which one you label as x sub 1, y sub 1, x sub 2, and y sub 2. It does not matter. If you switch them, it's fine because the answer is going to be the same. Okay, so let's just go ahead and I'm going to say this is x sub 1, y sub 1, x sub 2, and y sub 2. And I'm going to plug that into my distance formula. Okay, so it's x sub 1 minus x sub 2. Double check. Oh. Switch those. X sub 2 minus x sub 1, that's squared, plus y sub 2 minus y sub 1, that's squared. Okay, so I'm going to plug in my values. So x sub 2 is 7, and x sub 1 is 2, square that, plus, okay, y sub 2 is 4, y sub 1 is -5, be careful with that negative, and that's squared. Okay, so we're going to clean this up a little bit. So 7 minus 2 is 5. Okay, 4 minus a negative number, that's going to be plus. Okay, so 5 times 5 is 25, plus 4 plus 5 is 9. Okay, that's squared. Come up here. So we got 25 plus 9 times 9, that is 81. Okay, and then 25 plus 81, that is 106. Okay, I can't break 106 down into, say, like this. I can't break it down into, say we had, let's just look at this just for an example. This is not part of the problem here. D is equal to, or say the distance was equal to the square root of 8. Now we could write that as this right here. I can write that as 4 times 2. I can break those apart as the square root of 4 times the square root of 2. Well, the square root of 4 is just 2, so that would be 2 square root of 2. I can't do that with 106, the square root of 106. So that's going to be my final answer. So the distance between these 2 points is the square root of 106. Okay, so here's a nice and neat version of what I just did right there. Our final answer is 106 because we cannot simplify it any further. So that is when you're given 2 points. Now let's look at when you're given just a graph. So find the distance between the points on the graph. So I need an ordered pair for this point and for this point. Okay, so for this first point here, it's -3, 4. Okay, so I'll write it up here, -3, 4. And then for this one, it is 5, 2. Okay, again, it does not matter what I label these ordered pairs, because even if I switch them, they're going to come out to the same answer. So I'm just going to say this is x sub 1, y sub 1, x sub 2, y sub 2. Okay, so let's plug that into our distance formula. Okay, so we got x sub 2 minus x sub 1, that's squared, plus y sub 2 minus y sub 1, that's squared. Okay, my x squared is 5, minus x sub 1 is a negative 3. Be careful with that negative. Okay, my y sub 2 is 2. Okay, minus, and my y sub 1 is 4. Okay, that's squared. Okay, so this is going to be 5. A negative plus, or times a negative is a positive 3. Plus, okay, 2 minus 4. The bigger number has a negative, so I'm going to have a negative number. So basically 4 minus 2, that is 2. Okay, squared. Okay, 5 plus 3 is 8, so 8 squared. And then plus a negative times a negative, since it's squared here. Negative times a negative is a positive. 2 times 2 is 4, so this is 4. Okay, so then we've got D is equal to 8 times 8 is 16 plus 4. So D is equal to the square root of 20. Oops, I'm sorry. 8 times 8 is not 16, that's 8 times 2. 8 times 8 is 64. Okay, so now this is the square root of 68. Now we can break 68 up into 4 times 17. And then we can break that up into the square root of 4 times the square root of 17. I can't do anything with 17, the square root of 17, but I can change the square root of 4 to 2. So it's going to be 2 square root of 17. And that should be our answer for the distance between the points on this graph over here, if I get rid of all my markings. Okay, so the distance from this point all the way to this point is the same thing as 2 times the square root of 17. Okay, and here is a nice pretty version of the work right there. And there is your final answer, 2 square root of 17. Okay, let's do this one. Find the distance between the points on the graph. Okay, so same thing. First of all, I've got to find the order pair for the endpoints on this graph, and then I can plug it into my distance formula. Okay, so for the first one, looks like we've got -1, and go all the way up, 6. Okay, so this one is -1, 6. Okay, and then go over, that's 3, and -2. So 3, -2. Okay, so I'm going to label this as x sub 1, y sub 1, and this as x sub 2, y sub 2. And then I'm going to plug this into my distance formula. So x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so we've got x sub 2 is 3 minus x sub 1, which is a -1. I'm going to put that in parentheses. Plus, y sub 2 is a -2. Don't have to put that in parentheses, it's at the beginning. Okay, minus y sub 1, which is 6. And then square that. Okay, so I've got a negative times a negative, so that's going to give me a positive. So plus 1, the whole thing squared, plus, negative 2 minus 6, they're both in negative, so it's like we're adding the numbers but keeping the sign. So that's going to be -8 squared. So that's 4 squared. Plus, negative times a negative, that'll give me a positive. 8 times 8 is 64. 4 times 4 is 16, so 16 plus 64. And that's going to give me the square root of 80. We can break 80 up into 5 times 16, or I'm going to write it the other way, 16 times 5. Then we can break that up into the square root of 16 times the square root of 5. Square root of 16 is 4, times the square root of 5. And that's going to be our answer. So the distance between this point here and this point here is 4 square root of 5. And here is the nice and neat version of the calculations right here. And there's your answer.